All right, question number 5. We have a red cart, mass 2 kilograms, initially going 4 meters per second west, and it collides with a blue cart, mass 5 kilograms, initially going 3 meters per second east. It says after the collision, they stay stuck together, and they want you to find what will the VF be. Okay? So we go to our equation, m1v1 initial plus m2v2 initial is equal to m1v1 final plus m2v2 final. But they stay stuck together, so the v finals are the same, so you can factor it out. So it'll be m1 plus m2v final. Now you can write it in the front. I just wrote it in the back because it was following the m's. But you know that it's absolutely no difference when you're multiplying whether this VF is in the front or in behind. So if I'm screwing you up by putting it in the back, haul it out to the front, okay? And neither of these initial terms cancel because they're both moving. Now we want to solve for VF, so divide by M1 plus M2. Okay, it'll cancel over here. So we'll have VF equals M1 was 2 kilograms. And V1 initial was 4 meters per second west, so it needs to go in as a negative. M2 was 5 kilograms, and it was going 3 meters per second east, so it goes in as a positive. Divided by 2 kilograms plus 5 kilograms. On the top, negative 8 plus 15 should be negative 7. Kilogram meters per second, no, positive 7, sorry, and on the bottom 7 kilograms. So VF, because the 15 was the positive there, VF is equal to 1 meter per second, and it works out to be positive, so it's east. Okay, that's part A. There's actually a part B to number 5 that wants to know the impulse on the red cart. So J is equal to M delta V, or M VF minus VI. So the red cart's mass was 2 kilograms. The VF is what we just found, 1 meter per second, and it was east, so it goes in as positive. And the initial was 4 meters per second west, so it goes in as negative. 1 minus a minus 4 is positive 5. And 2 times positive 5 is 10 kilogram meters per second, and it works out to be positive, which means it's east. That is your answer to B. Number 6 says, a 4,000 kilogram truck traveling east 8 meters per second. So 4,000 kilograms. And V truck initial is 8 meters per second east. I could call it 1, I just thought I'd put a T there. When it hits a 2,500 kilogram car traveling west, so V of the car initial is 6 meters per second west. They lock bumpers, find the common velocity. So M of the car, V of the car initial, plus M of the truck, V of the truck initial, will equal M of the car, V of the car final, M of the truck, V of the truck final. But remember, the V finals are the same, so you can factor it out, and you'll just have VF. And over here, the 2 initial terms, because they're both moving. So now to solve for the VF, divide by the masses. So VF will equal M of the car, V of the car initial, M of the truck, V of the truck initial, divided by the 2 masses added together. Car was going, whoops, I wrote west there, but I'm pretty sure it said east in the question. Yeah. So you need to take into account direction, so it'll be 2,500 kilograms times negative 6 meters per second, because it's the one going west, plus 4,000 kilograms times positive 8 meters per second, and then on the bottom, 2,500 plus 4,000. Okay? Type it into your calculator carefully, and you should get 2.62 meters per second. 2.62 meters per second, and it works out to be positive, which means it's going east. And that shouldn't be a big surprise because the truck has more mass than the car and it was going faster. So it would make sense that when they join together that they're going to end up continuing to go east. All right, next, we already did number 7, so number 8. Be good if I could count, wouldn't it? Says, a blue cart of mass 6 kilograms is traveling 12 meters per second east. So 6 kgs, and V blue initial is 12 meters per second. It collides with a red cart of mass 10 kilograms, so 10 kgs, moving in the same direction. So V red initial is this way. 2.8 meters per second. And they're both east. Okay? After the collision, the blue cart continues to move east, so V blue final, 2 meters per second east, and it wants to know V red final for part A. So, M blue, V blue initial, M red, V red initial, I think I should have used 1 and 2, equals M blue, V blue final, M red, V red final. We're looking for the red final, so bring this term over, it becomes negative. V initial plus red initial minus blue final, and then to get the red final velocity alone, divide by the mass of the red. Okay, fill in your numbers. Everything is going east here, so we don't need to stress about negatives, so it will be 6 kilograms times 12 meters per second plus 10 kilograms times 2.8 meters per second minus 6 kilograms times 2 meters per second. And that negative comes because we took it across the equal sign, just in case you're wondering. Divided by 10 kilograms. Our F equals 72.28, so that's 100 minus 12 is 88, divided by 10 should be 8.8. Works out to be positive, so it should be east. That's part A. Part B wants the impulse on the blue one. So J equals M delta V, M VF minus VI. So on the blue guy, it was 6 kilograms. His final speed was 2 meters per second, and his initial speed was 12. 2 minus 12 is negative 10 times 6 is negative 60 kilogram meters per second, and the negative means opposite the direction he was going, so it means west. And then part C wants to know the net force on the blue cart if the impulse lasts 0.3 of a second. So we know J equals F delta T. So F equals J over delta T. So you can leave your negative in there if you want. 60 kilogram meters per second over 0.3 of a second. That's like 600 divided by 3. So negative 200 kilogram meters per second squared, or newtons, and that negative also means west. All right, one more, number 9, or maybe 2 more. I don't know how many I assigned you. What one was that? That was 8? Yeah, so I think I assigned you to 10. So number 9, that means I'm not going to get them all in here. A 10 kilogram object moving north, 6 meters per second, 10 kgs, VI initial, 6 meters per second north, collides with a 20 kilogram object moving south. Excuse me, 4 meters per second. After the collision, the first one rebounds.